Jai Hind. Today we are going to discuss decision tree, one method for classification in machine learning. We are going to discuss introduction, what are decision tree, their representation, the concept with the help of an example, how expressive the decision trees are, and finally we will conclude with the inductive learning of decision trees. So what decision trees are? These are mostly used for classification methods. In classification, we classify that a particular object, a particular data belongs to one of the classes which are defined according to the given domain. For example, if I take classes of digits, so I can have 0 digit, 1 digit, 2 up to 9. So I am having 0 to 9, 10 classes. So when we will be given some image, we have to identify which digit it is. So it will be 1 among 0 to 9. So that is the problem of classification. Classification we use daily in our each and every work. For example, let me say I am deciding that I have to take lunch now or not. So we are having two classes, yes or no, that is positive class and negative class. So in routine we do many things using classification. So we are going to discuss here a very important way, a very important model of classification, that is decision tree. So let us start with the definition, what type of structure it is, how do we use it. Decision tree. A decision tree takes as input an object or situation described by a set of attributes and return a decision, the predicted output value for the output. So it will take a set of inputs that are the attributes of the domain, and then it will give us the decision, that is our predicted output. And how this decision is taken? In decision tree, we reach to the decision by performing a sequence of tests. What does it mean? It means we will have a test on some attribute, then on other attribute, then on other attribute in a sequence. So after doing these tests in a sequence, we will reach to the final decision. Now, what type of structure it has? So when we are having some decision tree, let me say this is one example of decision tree, just a raw example. So if we talk about these nodes, these are internal nodes. So what internal nodes will be there in the tree? That will correspond to the test of the value of one of the properties. The domain will have some set attributes. Those attributes are the properties. So each internal node will make a test of the property, and then what will be there? Let me say I am having the decision, I am having this, that something like that. Now it is 5 a.m. So what is the test? Is it 5 a.m.? So what are the possibilities? Yes or no? So there are two possibilities. So there will be two branches. If I am having, let me say, weather, and let me say weather can be sunny, cloudy or rainy. So what I am having, either it is sunny or it is cloudy or it is rainy. So how many possibilities are there? 3. So the internal node in the tree correspond to a test of the value of one of the properties, and the branches from the node are labeled with the possible values of the test. What could be the weather? It could be sunny, it could be cloudy, it could be rainy. So those are the possible branches. Now the leaf nodes. What the leaf nodes will be? Each leaf node in the tree specifies the value to be returned if that leaf is reached. It will give us the decision. And decision tree are having the approach, a natural which is naturally generally used by the humans. We human do like that. So these are influenced by our human intelligence decision making. So that is the basic concept of decision tree. Let us understand with an example. When I am having let me consider the example of a restaurant. In this particular example, we are deciding that we will wait at the restaurant or we will not wait. So this we are setting as the learning problem. And what are the attributes to describe the example in this particular domain? So we are taking here 10 attributes. What are the importance of these attributes? First one is alternate. Alternate says that is there a suitable alternative restaurant nearby which can be have value true or false. There may be some alternate or there may not be. Second is bar. Bar is saying that specifying that is there a bar to wait in. If we need to wait at the restaurant, is there any bar where we can sit and wait? So again it is having two options, that is yes and no. Another attribute we are talking about, we are taking, that is for weekend. Is it Friday, Saturday? Yes or no. Fourth one is hungry. Are you hungry? Again yes or no. Patrons, how many are seated in the restaurant? It can have three values possible: no, none, some and full. The restaurant may have no customers, some filled, or it may be full. Price. What is the price of items in that particular restaurant? These may be, the price level may be in single digit, double digit or triple digit. Next is raining. It is talking about the weather outside. Is it raining? It can be yes or no. Next is reservation. Reservation is talking about did you make a reservation? So again, if made, yes, or if not made, no. Next attribute that we are having here is the type. It is the type of the food. The food can be French, Italian, Thai or burger. So these are the possibilities of the food. And the last one is the 10th attribute is talking about the wait estimate time. So the wait estimate, you may need to wait up to 10 minutes or 10 to 30 minutes or more than 30 minutes or more than 1 hour. So these are the possibilities. So we are going to understand our topic with these attributes. This is our example here. So one tree corresponding to that domain. So what we are talking about? We are talking about the wait at restaurant decision tree. So what will be the leaf node? Either we will wait or we will not wait, no or yes. Yes, 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 yes. These are the leaf nodes. In leaf nodes, we will take the decision. That will be the predicted output. Now, what will be internal nodes? As we have discussed, the internal nodes will have the test. So, test of what? Test of attributes. So, how many attributes are there? 10 attributes that we discussed on last slide. Alternate, hungry, wait estimate, patrons. These are few of the attributes. So, let us understand what this decision tree is representing. This is one example of the considered attributes. So, let me take the first one. So, firstly, what we are checking here? Patrons. So, patrons, none. None means empty. So, generally not taken by the people. So, the decision will be no. Some are sitting, the decision is yes. It means we are having space and we will be waiting for waiting to sit there. So, now the point is if full. In case of none, we will drop the idea. In case of some, we will take the seat. If the restaurant is full, now what is the point? I have to wait or I have not to wait or not to wait. So, what the point is? Wait estimate. So, what I checked here? Wait estimate. So, what are the wait estimate possibilities? How many branches will be there? It can be 0 to 10 minutes wait. It can be 10 to 30 minutes wait, 30 to 60 minutes wait or greater than 60. So, what we are saying here, if the wait is about 10 minutes only, that is 0 to 10, less than 10 minutes, then yes, we will take the restaurant. And if it is greater than 1 hour, no, the decision is no. We cannot wait for that much time. So, what we are considering here, if it is about 10 to 30 minutes, we'll check other attributes. If hungry, so again we are having two possibilities, no. Okay, it means we can wait for some time. So, our decision is yes. If hungry, then we will check immediately for is there any other possibility. So, what we are checking? Alternate. Okay, if there is no alternate, yes, we will wait. If there is alternate, we are checking is it raining outside. So, what we are having two possibilities, no or yes or no. So, if it is raining, yes, we will wait. If it is not raining, we will not wait. We can go outside. So, these are the possibilities. Now, if we are taking 30 to 60 minutes, it means we have to wait at least for half an hour and it may go up to 1 hour. So, we will check for some alternate. So when we are checking for alternate, so what the point here is, alternate can be yes, means there may be some alternate or there may not be. If there is some alternate, we will check, is it weekend? So Friday or Saturday? Yes. If it is weekend, then better to wait for the restaurant, because the alternate may also be full. And if it is no, if it is weekdays, then we will not wait, we will go for the alternate. Now, if there is no alternate, we will check for the reservation. If we have already reserved, naturally we will sit there only, we will wait for the restaurant. If no, then we will check bar. If we have not reserved, so is there any space where we can wait? So if bar space is there in bar, yes, we will wait, otherwise we will not. So this is one example of a decision tree. In this, we are having in our domain 10 attributes. From those 10 attributes, what we are doing, we are checking firstly on patterns, then on weight estimate, then according to weight estimate value, we are trying hungry and alternate, and in one case we are directly going to alternate, and then we are checking for reservation and bar, and one side we are checking for weekend. So what the point is, in internal nodes we are making the test, then according to that test we are deciding that which branch to take, and according to that we are deciding that we have to wait or we have to we are not to wait. So that is the point, the wait at restaurant decision tree. So this is our decision tree. Now in this, when we are having the concept of decision tree, we need to discuss two things. One is how to learn this decision tree. So we will talk about inductive learning, and one more thing we'll talk about, that is the expressiveness. So let us do one by one. Expressiveness. Decision trees are fully expressible within the class of propositional logic. It means if we are having class of propositional logic, so we can use decision tree for any problem. Any Boolean tree can be written as a decision tree. Each row in the truth table for each function correspond to a path in the tree, but may yield exponentially large decision tree. So what we want to say here is, if let me say we are having two variables, so for these two variables we can simply check one variable, it is having value Boolean, so it is true or false. Then we can go for second one and it will have value true or false. So if we see here, when we are checking P, it could be true value or false value. So it is showing us path true true, true false, false true, false false. So all the four possible values that we are having in our truth table. So Boolean for Boolean trees, it is totally convertible to our decision trees. All the propositional language class can be represented with help of decision tree. But decision tree are good for some kind of functions and for some it is not there, and there is no representation which is efficient for all the types of function, for all kinds of function. So for specifically Boolean languages, it is very useful. Now next thing is that we talked about ki we should know how to draw. If I talk about this particular example, how many attributes are there? There we were having 10 attributes. Now when we are having these 10 attributes, from these 10 attributes we selected patrons at the top, if we see our example, and then we checked that it is having value none, some or full. Then we decided second one, that is weight estimate. Now the question is, when we are having so many attributes, 10 attributes, then how do you take the decision that pattern should be taken at the top? So that we will talk about here in inductive learning. So what is given to us? A Boolean decision tree consists of a vector of input attributes x and a single Boolean output value y. So we will be taking decision from x and our decision will be y. So for learning this, for inductive learning, what is inductive learning? Inductive learning is, we are given data set and from the given data set we learn the rules. So that we are going to learn for decision making here in decision trees. So what we will be given? We will be given some positive example. In positive example, goal will be true. Then we will be given some negative example. In negative example, we will have the false goal. The combined set of true goals and false goals is our training set. So when we have the learning algorithm for decision tree, so what we have to find out which attribute should be checked first, because what we are doing in decision trees, we are checking the attributes one by one. Now the question is, which attributes should be kept at the top, and then then what should be the next one, then what should be the next one, and so on. So what is the basic idea? The basic idea behind the learning algorithm is to test the most important attribute. So firstly, we have to test the most important attribute. Now the point is, what is most important attribute? The most important attribute is the one that makes the most difference to the classification of an example. It means we are having two attributes. Let me say A attributes and B attribute. I am having these two attributes. If I am having few examples positive for this and few negative, that is false, and few can be both true or false, that depends on on particular attribute we are having final goal true always or false always, or it is a mix. Okay, so what the point is, sometimes what we are having, for some attribute it will be all true, for some attribute it will be all false. So if it is all true for one attribute, then that will give you decision yes. If the target value is false for some attribute, so that will be, the decision will be no. So we have to find these type of variables. Can we take the decision yes or no directly? And if it is not, then what should be the next attribute that should be checked to find this type of class? Okay, so that is the most difference to the classification. So we will get the correct classification with a small number of tests, with all small paths and small tree as a whole. So if we will take this decision, so our complexity of the decision tree will be comparatively low. We will have smaller number of tests. Otherwise, we can have more number of tests when we are drawing the decision tree. So let us understand the inductive learning with help of an example. So let us take in this example in which we are given 12 instances. So this is the data set. In this data set, what we are given x1, x2, x11, x12, total 12 example. If and I talk about the target is my will weight. If I talk about this target, I am having 1 true, 1, 2, 3, 4, 5, 6 true values, and same way 6 false, because in total these are 12. And I am having attributes alternate, bar, Friday, hungry, patrons, price, rain, reservation, type, and estimate of the time. So these are the 10 attributes. So I am having this for that particular domain, that example we took, for that we are having this particular data set. Now if we talk about the entropy of this particular data set in which we are having 12 instances, how do we calculate it? Entropy is the summation of probability of a particular variable into log to the base 2 probability of that variable. This is our entropy. So if I talk about the possibilities, it is true or false. How many total example are there? 12. So what we have taken 12, and how many are true? That is 6. So total probability is our 6 by 12 into log 6 by 12 to the base 2, and summation of all the possibility. What is the other possibility? That is of false. How many values are false? As 6 is true and 6 is false. This is the calculation for true values, and this is calculation for false values. How many are false? 6. So 6 by 12 is the probability into log of the probability of false values. So total entropy of this particular data set is 0.30. So this is our example. Now we will understand that how to find out the the most important attribute that can be kept at the top, that should be kept at the top. So one thing is we simply construct a decision tree with one leaf for every example, but that will be very much specialized and we will have a very lengthy decision tree, big decision tree. That is simple method. So what we are going to do here, we will do the use of inductive learning method, an advanced method of decision tree construction we will use. So what we will do here, in this we will split on each variable so that the purity of each split increases. Split means when I am doing this patterns decision, so what I am doing, what I am checking, I am setting here and then I am dividing into one according to none, one according to sum and one according to full. So that I am dividing. So that is the split. For example, if I am taking comparison alpha with 10, so what is the possibility? Either it will be true or it will be false. So what is my test? Alpha greater than 10. So I am having one branch for true, one for false. So what we want to check the purity of this split. How to check it? We do it in advanced method, that is the inductive learning, advanced inductive learning method of decision tree. So how we will decide it? We will measure the purity. The purity is measured with help of entropy. So if we take the entropy formula, what is the entropy formula? As we discussed on that slide of data set, entropy is summation minus of summation of probability of Vi into log of Vi. It is base 2. Log is the log is to base 2, log 2. Okay, so this is entropy. Now we'll see how to work out. So we will create pure nodes whenever possible when it is having 0 entropy. If pure nodes are not possible, then what we will choose? We will choose the split that leads to the largest decrease in the entropy. It means we will find out the increase in entropy for each of the attributes, and then according to that we will decide that which attribute will be checked first and which will be checked after that, and so on. So let us understand this concept with one by one. So first is our alternate. So we are having this, this is our data set, it is having 12 instances. When I see these 12 instances and I take the attribute alternate, so what I am having, alternate is true in these rows where it is highlighted with pink. True, 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 true. It means 6 times it is true. Okay, so we are having 2 values only, true and false, that we are representing here with false, yes and no. So now let me talk about this yes value. So how many I found? 6. Let me repeat again. 1, 2, 3, 4, 5, 6. So these are 6 values. What I am checking here? True. I am excluding false and checking true. False I will take here. Total examples are 12. It means 6 is corresponding to false and 6 is corresponding to true. Now let us check for true. The highlighted are true. So first one is true. It is also true. Second is false. In this line it is true. True. So for true alternate, let me repeat, for true alternate I am having 3 times true target. For true alternate I am having 3 times true target and 3 times false. So 6 is divided into 3 true and 3 false. So what I said, in alternate I am having 6 true values, 6 false values, and among these 6 true alternate values I am having 3 times target true and 3 times target false. Same way, now let us calculate for no, that is the case of false of alternate. Which are not highlighted, those are false. 1, 2, 3, 4, 5, 6. Now let us see corresponding to it. 1 true, 2 true, 3 true. So again we are having 3 true values and 3 false values. So for these 6 true values, we are having 3 and 3. Okay, so what I said, when alternate is false, I am having 3 times target true and 3 times target false. So what my entropy will be, from these total 12 examples, I am having 6 times alternate true, and from these 6, this is the entropy within that. This is 3 are true and 3 are false. From how many? From 6. So total positive examples are 6, and from these 6 examples, 3 are true and 3 are false. Now second part. What is the second part? From these 12 examples, 6 are false, 6 are negative. When we take 6 these as negative, from these 6, 3 are true and 3 are false. So this is the entropy of alternate within this false values. So total we have got 0.30. So now if I see the entropy decrease, the entropy of the whole data set was 0.30, and what is the entropy of alternate? That is 0.30. So what is the decrease? That is 0. So for this particular, we have got 0 entropy decrease. Now for another variable, what is another variable? Bar. So if now see I bar, this second one is bar. Here if I see again 1 true, 2, 3, 4, 5, 6. Again 6 are true and same way 6 are false. Now in these 6 true, 1, 2, 3. Again 3 are true and 3 are false. Same way for false values, 1, 2, 3. 3 are true and 3 are false. So it will be same as alternate. In this we will have the entropy value 0.30. So entropy decrease again is 0 in this particular also. So we have checked for alternate and bar. For both these we have got the entropy decrease as entropy value as 0.30. So entropy decrease is 0. This is our calculation for these two. Next we will check for Friday, Saturday, that is our weekend. So if I check here, it will be 1, 2, 3, 4, 5. So for Friday we will have yes 5 and no 7, because 5 are true. And if I see these 5 trues, in these 5 true, what we are having, this is true value. So 1, 2. 2 are true and 3 are false. Same way we can calculate for no. No we are having for 7. So for those 7, if we talk about these 7, 1, 2, 1, 2, 3. 3 are true and 4 are false. So corresponding from 12, how many are true? True are 5 only. So we will have 5 by 12, and in these negative we are having 7. So it will be 7 by 12, and within that, within those 5, 2 are true and 3 are false. Okay, so for this we will have the formula minus of probability into log of the probability. It means 2 by minus 2 by 5 into log of 2 by 5 minus 3 by 5 into log of 3 by 5. For now in next 7. So from 7, 3 are true. So this is minus 3 by 7 log of 7, 3 by 7 to the base 2 minus 4 are positive negative. So 4 by 7 into log of 4 by 7. So this way one by one we will calculate all the entropies. So when I calculate this entropy, finally I have written other values in this particular. slide table. So for Saturday, Friday, I got the entropy 0.21, sorry, 0.29, and the entropy of the whole data set was 0.30. So the entropy decrease is 0.01. For Hungary, we are having 0.24, so decrease is 0.06. On the same basis, we have calculated the entropy of the attribute. For raining, we are getting 0.30, so the decrease is 0. For reservation, it is 0.29, so the decrease is 0.01. For patrons, it is 0.14, so decrease is 0.16. For price, it is 0.23, so decrease is 0.07. For type, it is 0.30, so decrease is 0. For waiting time, it is 0.24, so decrease is 0.06. So now we are having full table. What is this full table showing? First two attributes we have shown on the previous slides, for which the entropy decreases 0 and 0, and then we are having these two. For first two variables, we were having 0, then 0, then 0.01, 0.06, 0, 0.01, 0.16, 0.07, and 0 and 0.06. So from all these, what we will see, what is the largest entropy decrease. As the largest entropy decrease is 0.16, and it is achieved by splitting the patrons. So on the top, we will take the patrons. It means the most important attribute is patron. So on the top, we will calculate the split of patrons only. This is the reason we have taken at the top among those 10 attributes patrons for the first test. Now when we see patrons, so for none we are getting all false values, so our decision will be according to that, no. For some we are having all true values, so our decision will be yes according to that, because all are true. But for full, we are having mix of true and false values. So what does it mean? It means we need to decide again that which attribute should be checked. So we will continue like this, making new splits, of always purifying nodes. So one by one we will decide the nodes and we will go on checking that. So in this way we will learn the decision tree. This is inductive decision tree learning. So from the given examples, how many examples were given? 12. From those 12 examples, we will calculate this. After patrons, we will get next important Hungary. After that, we will get next important type. After that, we will get next important Friday, Saturday. So this is the induced tree from our examples. And if we talk about these 12 examples, this is the decision tree. But if we talk about our example, original example that we started with discussion, this is the complete tree. We can see from here that it is having a different structure. Both started with patrons, but then the final structure is not same. That was the induced tree was very small in comparison to the actual tree, because this actual tree, true tree, is induced from number of examples. We were having a big number of examples, but now in this lecture we have taken only 12 numbers, so we have got this particular tree. So it is induced, the tree, decision tree is induced according to the given example from the data that is given in the examples. We cannot make it more complex than what the data supports. How much data is given? That is 12 instances. So it has been induced according to that. So in this particular lecture, we talked about the classification method, decision trees, what are decision tree, where these are used, and how we do inductive learning in decision tree. Thank you. Jai Hind.